Hello everyone, welcome to day number 12 of this series, of this challenge of doing physics questions every day until I get a girlfriend, okay? So, today we're only doing one question, which is this question. So yeah, let's get straight into it. So, number 4. The graph in figure 2.33 shows the variation of velocity with time of two cars A and B, okay, which are traveling in the same direction over a period of time of 40 seconds. Alright, car A traveling at a constant velocity of 40 meters per second. So it's car A right here. Let me change color actually. This is car A, right? My drawing is too good. And overtakes car B at time t equals to 0. In order to catch up with car A, car B immediately accelerates uniformly for 20 seconds to reach a constant velocity of 50 meters per second. So car A overtakes car B, and then car B wants to catch up with car A, so it accelerates, and it accelerates for 20 seconds. Alright, to reach a constant velocity of 50 meters per second, right here. Alright, calculate. Alright, see what I have to calculate here. Number A, how far A travels during the first 20 seconds. Alright, so the first 20 seconds, how far did A travel? Okay, let me delete this. So the distance, to find the distance in the graph like this, we do find the area under the curve, or area under the graph, to find the distance in the velocity time graph. Alright, so let's do that actually. I get my okay, so we find the area of this. So this is 20 and this is 40, so just multiply both that. Number A, I'll just say S, and it'll be 20 times 40, sorry, it'll be 800, I think, right? Yeah, 800 meters. So car A will travel 800 meters in the first 20 seconds. So 800 meters. Alright. Okay, so let's go to number B. B is, let me see, the acceleration and the distance of travel of B during the first 20 seconds. So I have to find the acceleration right here and the distance of B. Alright, so let me use a different color actually. That's a good idea. Wait guys, I'm sorry. Alright, so to find the distance, let's find the area under the graph here. Alright, so let's do that. So this is just a trapezium, right? So I'll just use the formula for that, which is area with, let's say, S 1 over 2 A plus B. I'm sorry for loud background noise, guys. A plus B and multiply by H. Alright, so yeah, A is this length. A is this length, which is about actually 50, plus B, which is about 25, and H, which is the height, is 20. So we do that. It's 10, 7, 5 multiplied by 10. That will get 750 meters. Alright, so this is 750 meters. My annotate is not doing well. It's not a square root. It's not a square root. 750 meters. Alright, so let's go to number C. We're already halfway. Okay, so number C, the additional time taken for B to catch up with A. So let's look at the first two questions, right? So at t equals to 20, car A traveled for 800 meters and car B traveled 750 meters. So car B hasn't really catch up with car A, even though it has more velocity. It hasn't catch up. So this question is asking about like how long will it take for car B to catch up with car A after the acceleration, after t equals 20. Or no, not after t equals 20, but how much additional time will be taken to catch up B. But okay, so do that. So let's see here. So car B goes at an acceleration of 50 meters per second. Car A travels at a velocity of 40 meters per second. Okay, so now the velocity difference between this is gonna be 10 meters per second. Alright. So to know time, we need time equals distance over speed. Speed. Distance we can get from the two questions here. So the difference in the distance is 50 because car A traveled for 800 meters and car B traveled for 750 meters. That difference between those values is 50. So yes, I will use 50. So let's write that down. So velocity is gonna be 10 meters per second. The difference, talking about the difference here. The number t or time will be not time. The distance will be 50 meters. So I just need to do time, right? So the time equals to distance over speed. So we'll get 5 seconds. Alright, 5 seconds. So the B will take an additional 5 seconds to catch up with car B after t equals to 20. So at t equals to 25, I believe. Yeah, 25, car B will catch up. That's what I'm talking about. Like this question saying like after t equals to 20, what additional time will B take to catch up with A? So yeah, 5 seconds. Or at t equals to 25 seconds. Alright. Let's go number D here. Same color. Pick yellow. No, yellow things too. Okay. So let's go number D. The distance each car will have then travel since t equals to 0. So this is talking about the whole journey, the distance that they travel throughout the whole journey, right? So yeah, let's do that. So okay, so here car A. That's too much annotation right here. Okay, I'll delete these. Alright. So distance each car will travel since t equals to 0. T equals to 0 is here. So I need to find the distance that both cars will travel. So car A will have traveled for about, so this is 40, and that's also 40. So distance, and this is 40, and length is 40, so just multiply both. So 40 times 40, that is 1600 meters. Alright, so now let's do for car B. Like it's a distance since t equals to 0, so that's since the start. Alright, so here we go. So this is just two separate things. We already found the distance of this, so we can find this. So which is that's a rectangle. So car B distance, we use the old distance, which is 750 meters. Oh wait, I forgot to find the acceleration here. Okay, I'll do that after this. I'm sorry, I forgot to find the acceleration. Okay, 750 plus 20 multiplied by 50. Okay, So 750 plus this is 1,000. Not 1,000. This is 1,000. So 1750 meters. So as you can see, the answer to this question is 1750 meters, 1,750 meters. Okay. Alright. What's the answer to number C? Is 25 seconds. Okay. So let's find the acceleration of B right here. I'm sorry, I forgot. Okay, so the acceleration is a gradient. So I need to find the gradient. I'll just use the normal acceleration question right here, right? So you go to V minus U over T, and that T looks like an A. So V velocity, the final velocity is 50, inertial is 75, T is 20. So we get 25 over 20. I just use a calculator. I don't even use a calculator. 5 is 4. So 5 over 4 meter per second square. And in decimal forms, it would be 1.25 meters square. And that will be the acceleration of B in the first 20 seconds. Okay. 1.25 meters square. Okay guys, so this will be the end of today's episode. I'm sorry. So yes, we'll see you tomorrow. Bye bye.